strategies for multiplying polynomials, okay? I have here a binomial times a binomial. So they're two polynomials together. And so one strategy, if I had the tiles, I could use the tiles. But you know, I'm not going to just carry around a bag of tiles with me all the time. So we could draw it. That is something you can do all the time, whether you have tiles or not. So my strategy, if I was going to multiply these, by the way, it doesn't matter which one is the base and which one is the height because of the commutative property of multiplication. So if my base was 2x plus 3, remember we're going to go 2 x's and then 1, 2, 3. And if my height is 4x's plus 5, I might run out of room. 1, 2, 3, 4, I am. So let me just really quick start over. Sorry, guys. All right, so 2x's plus 1, 2, 3, and then 4x's, 1, 2, 3, 4, plus 5, 1, 2, 3, 4, 5. I'm going to make my rectangle. So I chose this one on purpose to show you, like, sometimes it's just really annoying to try to draw them, which is a good reason to have a way that we're going to do after this. So I have my 1, 2, 3, 4, and then 1, 2, 3. Okay, so you see mine's not perfect either. So I had, this was 2x plus 3. This one was 4x plus 5. And then if I wanted to figure out what my final answer was as an area of the parts, so these guys are my x squared tiles. And then I've got x tiles here. And then these guys are my ones. So final answer, if I multiply 2x plus 3 times 4x plus 5, I'm going to end up with 1, 2, 3, 4, 5, 6, 7, 8 x squareds plus 3, 6, 9, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 plus 22 x's plus 3, 6, 9, 12, 15, and then that would be my area as a sum. Okay? Questions on that? Again, you see how like I had to kind of start over again. It got a little annoying. I might, if I'm not very careful, my x's might look like my x squareds, right? So you kind of got to be careful. So let me show you how we can do it generically now. When I'm going to show you a generic rectangle, I never learned this way when I was your age. In fact, I never learned this way until I had to teach it this way, maybe 10 years ago. And now I like it. I like it, like it, like it. You can always do it this way. It's a good, really basically a graphic organizer so that you don't miss anything.
How did they do it before?
I'll show you. We'll do that the third way, okay? So yesterday, just a little aside, yesterday I asked some of you to do 2x plus 1 times 2x plus 1, and you said it was 4x squared plus 1, right? What happened was we missed some of those middle terms. So this way, using a generic rectangle might help you so that you don't forget any of those middle terms. So here's what we're going to do with our generic rectangle. First of all, I'm just going to make a generic rectangle, right? It's not to scale, it's just a rectangle. And then I've got my base is 2x plus 3. So here's what I'm going to do. This has two terms, right? So I'm going to separate my base into two parts. I've got my 2x term, and then I have my plus 3 term. And then my height has two terms. So I'm going to separate my height into two spots. I've got my 4x spot, and I've got my positive 5 spot, okay? Now listen, commutative property, it wouldn't matter if I switched these two, okay? It wouldn't matter if I switched these two. Doesn't matter because you'll end up with the same thing after you're done. So now I'm just going to kind of like match them up. So this rectangle right here is 2x times 4x, which is 8x squared, okay? This rectangle up here is 2x by 5, so 2x times 5 is 10x, This rectangle over here is 3 times 4x, so that's 12x. And then this top rectangle is 3 times 5, which is a positive 15. Okay? And then my final answer, I'm going to combine like terms always. And if you notice, these guys are like terms. So my final answer is 8x squared plus 22x plus 15, which is what we got last time. Okay? Now, it took a long time because I was explaining it as I went, but some people get really fast and just make your generic rectangle, blah, 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 you're done, okay?
I have 2 questions. Can
What?
you do it without the generic?
Yep, I'll show you that next. Second?
And what happens if it's like terms? Like the 2x's, like
I combine them together. You mean if these are like terms?
Yeah.
So if I had 2x plus 3x, I would just make that 5x right from the beginning, and then you could just use the distributive property, okay? So if in your parentheses we have like terms, you could simplify that ahead of time, and then you don't have as much work to do. So definitely, okay? Sean?
What do you do when there's negative? But not with that way, but with the other way. Like the first way that you did with the tiles?
Yeah, so that's the other thing about doing it with the tiles. If, because it's hard to show when you're multiplying the negatives, usually we would shade in a negative tile. But yeah, so that's another thing with the tiles. It's nice to show space, but it's hard to keep track of your negatives and your positives with the tiles. So that's another reason why a generic rectangle would be better. Okay? More efficient for you. Julia?
Does it matter what order you write the terms in?
Okay, so your final answer, guys, should be in descending order by exponents. So I've got my x squared first, then my x first, and then my number, okay? My constant. If I happen to have 2 different variables, usually we'll put it in alphabetical order like, okay, I'm just gonna make this up. Let's say I had some and I had x squared plus 3xy plus 4y squared. See how my x squareds went in descending order? X squared, and then this is x to the first power, and then this is x to no power. So generally, that's how we write it, okay? All right, cool with that? Generic rectangle, I highly suggest that you do that a lot so that you don't miss these middle terms. A lot of people forget those middle terms. Okay, let me show you now without that, because some of you are already doing it this way. So this last way, I learned it as FOIL. You don't necessarily have to use the whole FOIL idea. It's basically just a double distributive property, okay? So if I'm multiplying 2x plus 3 times 4x plus 5, the way I look at it as, let's say you had 2 teams of tennis players, okay? You got Central's tennis teams, you got Dowstown's tennis teams, okay? Now, if Alora and Caitlin were on Central's team, okay? And then if Haley and Claire were on Dowstown's team, well, Alora and Caitlin don't play each other, right? And Haley and Claire don't play each other, but they would each have to play the other people on the team. You with me? So you don't play your own teammates, you just play both people on the other team if we were doing like a tournament thing. So it's that same idea, okay? FOIL stands for first, outer, inner, and last, okay? Again, you don't really have to. If you like that, great, but you don't necessarily have to think about it that way, okay? So first, I'm going to multiply the first term in each set of parentheses. So 4x times 2x is 8x squared, right? Then I'm going to multiply the outers, so that would be the ones on the outside. So 2x times 5 is 10x. Then the inners are the 2 that are on the inside here. So 3 times 4x. Now watch what I will do here. 3 times 4x is 12x. That is a like term with 10x. So I'm going to write them underneath each other so I remember to combine them. And then my outer, or my last, are the last ones here. And then that would be plus 15. So final answer, 8x squared plus 22x plus 15. Okay? So again, that was using FOIL, but do you have to necessarily think of FOIL? No. What I do is I take this first guy, right? Let's say that's Alora. She's going to go against Haley and then Claire, okay? And then Caitlin's going to go against Haley and then Claire. So it's a matter of making sure the first term gets multiplied by every term in the other parentheses, and then the second term gets multiplied by every term in the next set of parentheses, okay? So whether you like the idea of FOIL, double distributive property, generic rectangle, totally up to you. Okay.